So now we're going to start looking at some applications of derivatives. And one of the most common applications is to be able to find absolute or relative minimum or maximums using the first, or in other words, known as the first derivative test, or using the first derivative test, I say, to find these. So the first thing you want to do is when you're trying to find generally what a relative maximum is it's potentially where the first derivative is 0. Okay, so the key part is if I have an interval and I'm attempting to find the minimum or maximum, I want to look at the endpoints of the interval as well as any critical numbers on the interval, and then I would just look to see which one is the minimum or maximum. So in this case, here's the maximum, and if I drew my picture more like this one would be my absolute minimum. Okay, but these two are local minimum. This is a local maximum, this is a local minimum, because this one is like larger than the points around it, and this one is smaller than the points around it, like its lowest point. And then these are just simply endpoints. They're not relative min or maximums. Okay, so in this case, what we're going to do is we're just going to simply execute by saying, okay, find the absolute and minimum value of the function in the given interval. So first, I have the interval. So my candidates are always any critical numbers as well as the endpoints. So I'm going to take the derivative. To find the critical numbers, I need to set the derivative equal to 0. Or where it's not defined, but more commonly it's where the derivative is just equal to 0. So we would have 2x plus 1 is equal to 0. And I solve for this, x would be negative 1/2. So this is my only critical number here. Then I also want to check the endpoints. So I create a table here, x and f of x. This is negative 1/2. My other candidates are negative 1 and 2. And then what I'd simply do is I just evaluate what's f of negative 1/2. That's going to be negative 1/2 squared plus negative 1/2 plus 4. So that's 1/4 minus 1/2 plus 4. What's that? Minus 1/4. That's like 3 3/4 then, right? When I plug in negative 1, it's going to be 1 minus 1 is 0 plus 4 is 4, and then 2 is 4 plus 2 is 6. 6 plus 4 is 10. So what's the minimum? The minimum is right here. This is the smallest number that I get, and this is the biggest number. So the minimum is 3 3/4, and the maximum is 10. Okay, so that's all we're gonna do for absolute mins and maxes. So we're gonna do the same thing here. I want to check the endpoints. So if I were to create my table here, I want to check the endpoints, and then I want to check any critical numbers. Critical numbers are where the derivative is equal to 0. So the derivative of 3 sine x is just 3 cosine x, because the derivative of sine x is cosine x, and the 3 just sits there because it's a constant in front. And that's equal to 0. So I need to know when cosine of x is equal to 0. If I think about my unit circle, that happens when it's 0, but 0 is not my interval. It happens at, actually not at 0, sorry, at pi over 2. That's where cosine of x is 0. So pi over 2 is in my interval, so that's, like really the interval, this interval is pi over 4. That's going from pi over 4 to what? Pi over 3, 2 pi to this point here. So this is the only critical number, because I could go all the way down here to 3 pi over 2, but that would be outside of this interval range. And so I just want to do 3 sine of pi over 4. That's 3 root 2 over 2. 3 sine of 2 pi over 3. Well, sine of 2 pi over 3 is going to be root 3 over 2. So that's going to be 3 root 3 over 2. And then when I plug in pi over 2, it's going to be 1. So that's going to be 3. Now, in terms of largest and smallest, let's see which one is the largest. Well, this one is the largest because the root 3 over 2, root 2 over 2, these are all less than 1. So if I think about it, this is my maximum. And then my minimum, well, square root of 2 is smaller than square root of 3, so this is my minimum right here. Okay. All right, let's do the same thing here. Now, some people might ask, when we do this candidate test, I kind of want to get into, like, why am I not doing the actual first derivative test to find relative mins and maxes? And you certainly could, but because in these questions are asking for both the min and the max, it's sort of irrelevant. Because I'm going to have to compare them anyway, So there's not necessarily a good point in classifying the critical points necessarily. It's not necessarily going to tell you a lot because you're going to have to check it anyway to find the min or the max. So we're kind of just shortcutting it a little bit. You could theoretically do the first derivative test to classify whether it's a relative min or max. In later problems, we're definitely going to do that. But in these problems, we don't necessarily need to do that when you're finding absolute. So I want to check the endpoints. Those are candidates. And I also want to check when the first derivative is equal to 0. So I need to compute the derivative here. Now, I'm going to write this as x squared, and I write these as 8 minus 2x squared to the 1/2. That way I can apply the power rule correctly, okay? And I'm going to apply product rule here with some chain rule. So the derivative of this is I take the x squared times the derivative of this one, which by power rule, I make it 8 minus 2x squared to the negative 1/2. But because the inside's not x, when I did this applying the power rule, I got to multiply by the derivative of the inside, which would be derivative of 8 is 0. Derivative of 2x squared is 4x to the first power. And then plus, I'm going to do the derivative of this times this. 2x times 8 minus 2x squared to the 1/2. Now, I'm going to set this equal to 0. And the easiest way to do like this is not an easy equation to solve. But what I want to do is I want to factor out the common terms from both. So I have an x in both, and let me see. This 1/2 will cancel with that to get 2. So I really have a 2x, and then I have a term like this, 2x squared, and I always use the lowest power. So negative 1/2 is smaller than 1/2, so we do negative 1/2. Okay, and then now I'm going to see what I have left over. So I took out an x, so I took out this 2x here, and I took out this term. I took out all of this, so I'm just left with negative x squared for the first term. And for the second term, I took out this 2x already, but I took out one of these, and I have to think about what times this will give me this. If you think about it, it's 8 minus 2x squared to the first power. Because of the first power times this one, this negative 1/2, I add them together, I'll get this positive 1/2. And so this is nice because I can combine these. This ends up being 2x 8 minus 2x squared to the negative 1/2 times negative x squared minus 2x squared is minus 3x squared, so that's 8 minus 3x squared is equal to 0. Now I'm going to move this into the denominator because that helps it easier for me to see how I'm going to set this equal to 0. So this part is going to move to the denominator and make this a positive exponent, and everything else is going to stay up here. And what this allows me to do is to know that when I'm dividing two numbers, the numerator must be 0 if they're equal to 0, right? Because the only way I can get 0 is if the top number is 0. 0 divided by anything is going to be 0. Okay? So really, I just need this part to be 0, which is nice because I get rid of that square root of part. And so this tells me, well, 2 can't be 0, x can be 0, or this part is 0. And if this part is 0, then x squared would equal 8/3. And so x is going to be plus or minus the square root of 8/3. Now, square root of 8/3 is definitely going to be between these points because the square root of, 8/3 is like close to 3. Square root of 3 is definitely less than 4 or negative 4, right? So I have two candidates here, the square root of 8/3 and the negative square root of 8/3. Okay? And now I'm going to plug it into this equation again. So when I plug in negative 4, I'm going to get 16 here. I'm getting 8 minus 16. That interval, it doesn't actually exist because I do 8 minus 16, or 8 minus 32 is going to be a negative number. I can't take the square root of a negative number. So this interval is actually outside of this domain. You see that? So I actually can't use these as my endpoints. I got to think about what my endpoints are. The restriction on the domain is this has to be greater than or equal to 0. So really my endpoints are going to be 8 is greater than or equal to 2x squared, or x squared is less than or equal to 4. And so that's x has to be between 2 and negative 2. So really, these are not my endpoints. It's really negative 2 to 2. Okay. So because I can't plug in 4 or negative 4 to get that. So I really got to do negative 2 and 2. Okay, but when I plug in those points, when I plug in like 2 or -2, I'm simply going to get 0 because this part is going to be equal 0. It's going to be 2 times 4, which is 8. 8 minus 8 is 0. So these are 0. Now what happens when I do the square root of 8/3 is it's going to be x squared, which is just 8/3, times the square root of 8 minus 2 times 8/3. Right? Because anywhere there's an x squared, it'll just become 8/3. And so this will be 8/3 square root of 8 minus 16/3. This is 24/3. 24 minus 16 is 8/3. So 8 root 3, 8 root 3. This is really 8/3 to the 3/2 power, right? And note that because I'm squaring it, this is an even function, right? Like when it'll just get the exact same number here. And so my minimums are 0 and my maximums are this one. Okay. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.